Suppose our hypotheses are given to us as follows. The null hypothesis is that the population mean is 315. Mu equals 315. And that represents in context that the kids in our school district spend an average of 315 minutes using screens during the weekend. The alternative hypothesis is that mu is not 315. That is, that the average amount of time that kids in our school district spend on screens is not 315 minutes. It's some value that's higher or it's some value that's lower. So suppose we then go out, collect a random sample of kids in our school district, and our sample has a sample statistic of X bar equals 318. So our sample mean from our kids that we sampled is 318 minutes average screen time. We then use the applet. We create 100 simulated repetitions on the applet to get 100 sample statistics as displayed there. And now we're going to answer some questions. So part A says, what value is this distribution centered at, and how do we know that even without selecting the summary stats button in the applet, or even looking at the picture? Well, the way we know is that we know that when we do a hypothesis testing process and we create a simulated distribution of sample statistics, we do that under the assumption that the null hypothesis is true. We assume the null is true and we create a simulated distribution of sample statistics based on that assumption. The simulated distribution of sample statistics will be centered at that value from the null hypothesis, or close to it since it's a simulation. So our distribution should be centered at a value very near 315, which it seems to be. 315 seems to be in the middle. So we say that this distribution is centered at approximately mu equals 315, since that's the value hypothesized in the null hypothesis. It then asks us to find the p-value and explain how we can do that with the graph. Okay, so to find a p-value, we need to know our sample statistic. Our sample statistic, recall, was x bar equals 318. A p-value is the probability of getting a sample statistic like ours or more extreme if the null hypothesis is true. So it means we need to count sample statistics in the distribution that are like 318, which is right here, or more extreme. More extreme means further out from the tails. So 318 is here. There's 3 dots above 318. There's another 2 dots, 1 notch to the right, and there's another 1 dot here. So on the right side, more extreme than 318 is 6 sample statistics on the right side. Now, how do we count those on the left side? Remember, we do have to count sample statistics on the left side because our alternative hypothesis has a not equal to sign. Therefore, this is a two-tailed test, which means we're going to count sample statistics that are like 318 and higher. But we also have to go to the left side and count sample statistics that are like that and lower. What does it mean to be like that? Well, it means equal distance. So the middle of this distribution is 315. Our observed sample statistics is 3 units higher to get up to 318. We need to now go 3 units lower to find an equal distance lower. That would be 312. And we're going to count sample statistics that are like 318 and higher, like we already did, but we're also going to count sample statistics that are like 312 and lower. So equal distance away from that center. And it looks like there is 1, 2, 3, 4, 5, 6, 7. 7 sample statistics down here. So 6 on the right side, 7 on the left side. Okay, so let's summarize that. The p-value was found by counting all the sample statistics that are like our observed sample statistic and more extreme. Our observed sample statistic was 318, And the alternative hypothesis is that mu was not equal to 315. And because it contained a not equal to symbol, we need to count squares or dots that are like our statistic or further away from the center. So what I did is I noted 318 is 3 units above the center. On the left side, 312 is 3 units below the center. So we count squares that are like 318 and higher, and also count squares that are like 312 and lower. There's 6 squares that are on the right side and 7 squares on the left side. So totally, 6 squares plus 7 squares is 13 squares out of a total 100. So 13 out of 100 is 0.13, 13%. The p-value is 0.13, 13%. And part D, what conclusion do we make about the hypothesis if we're using a significance level of 0.01? Well, we note that the significance level is alpha equals 0.01, and our p-value is bigger than that. Our p-value is 0.13. When your p-value is bigger than the significance level, you conclude that the null hypothesis is plausible. So in context, we conclude that it's plausible that the kids in our school district spend an average, a mean, of 315 minutes using screens during the weekend.